Welcome to the 9th Delphi Forum and our panel today on rising tides, rising threats, safeguarding our ocean in a warming world. On the one hand, the world seems to be coming together on the need to protect our oceans, close gaps in ocean governance, and improve ocean literacy. To these ends, we are now almost halfway through the UN's Ocean Decade, which aims to reverse the cycle of decline in ocean health. We also have a High Seas Treaty, known as the BBNJ, and in just a few days, Greece will welcome the 9th Our Oceans Conference. Yet this year, we saw record highs for sea temperatures, continued biodiversity loss, acidification, eutrophication, and declining fish stocks, and much more throughout the world. It all leaves one to wonder if it is almost too little too late. In this panel today, we will take a look at the status and health of our seas, the ways innovation can be mobilized to make a positive impact, and what else needs to be done to better protect and restore our seas. With us today, we have a group of very prestigious speakers, and I would like to introduce Maria Damanaki, Independent Advisor on Climate Oceans, the former EU Commissioner for Maritime and Fisheries. We also have Hercules Haralambides, Professor of Maritime Economics from the Erasmus University, Rotterdam. Dr. Elisabeth Lipiatou, Head of Unit from the Directorate General Communications Networks, Content and Technology. Kostas Lagouvardos, Research Director from the National Observatory of Athens. And Mr. Lars Ebbesson, Program Director of Sustainable Ocean Harvesting.
Switch places.
Professor Lagouvardos, can you set the stage for us and explain a bit in more detail about the ocean climate nexus and what is happening with the rising sea temperatures?
Okay, thank you, Cheryl. Of course, one of the things that we have to see when we study oceans is the sea surface temperature. Sea surface temperature is one of what we call the essential climate variables that are used in order to follow the climate change, together with the concentration of CO2 and extension of ice sheets. So sea surface temperature is a very important parameter.
Can you speak louder?
The microphone.
Please.
It's open. You can hear me?
Speak louder.
Huh? Okay. I think it's better now.
Yes.
Okay.
Yes.
If we look at some maps, for example, on the world scale, you can see that everywhere on the seas we have now, and also for many weeks now, very high temperatures, much over the normal values, as we call. And for example, in North Atlantic, we have now almost 400 consecutive days with a large deviation of temperature from the normal values. And if we focus on the Mediterranean, we can see that the Mediterranean is a hot spot also for SSTs. We have very high surface temperature even for this month, especially in the central and eastern part of the Mediterranean and also in the Black Sea. And then we can go to Greece and see what's happening. For many months now, sea surface temperatures in all Greek waters are much over the average, the normal, the climatic values. For example, 2 days ago, we have 3 degrees more than the average on the northern part of the Aegean Sea, 1.5 to 2 degrees in the central and southern part. It's a very large deviation from what we call the normal situation. And then we can remember, for example, cases like what happened last July. Last July, we have a very important, a very long-lasting heat wave, an atmospheric heat wave, that also produced a marine heat wave. And for the first time, we saw, for example, sea surface temperature in the Ionian Sea, on the western part of Greece, over 30 degrees. It was something that has never happened so far. And someone can say, okay, this was coincidental, or it can happen from time to time. So the most important, and I will finish with that, is to follow the trend. And we have data from satellites, from buoys, from ships, and so we can reconstruct the surface temperature for many years in the past. And if you look, for example, in the last 30 years, at least for the Greek waters, but this is more or less the same for the whole Mediterranean, we have more than 1.5 degrees increase in temperature during these last 30 years. A very high increase for such a short period. This has many consequences we will discuss with our colleagues later on. including weather, but this will come later on. Okay, thank you.
Thank you. So yes, going right to the impact of this increase in sea surface temperatures. Commissioner, can you please tell us a bit more about how this rise in ocean temperatures is impacting marine biodiversity, ecosystems, and also local populations?
Yeah. This is a very important question, and this is exactly what we have to find out and see how we can reverse it. I don't want to add more scientific data on what Mr. Lagouvardos already said. Just to add a number, only one number, we had this great meeting in Montreal last year, the coming Montreal meeting by United Nations about biodiversity. And there, what is the summary of all the data gathered? It was that the biodiversity now is 100 times to 1,000 times less than the normal. So the way it is decreasing, it's disastrous. And the worst is that it's getting worse every year. So you are right, the situation is deteriorating. We have to do whatever we can right now. And that's why I think it was a positive decision, the decision that was taken there by all countries, or the great majority of them, to protect 30% of the planet lands and ocean until 30. This is the 30 by 30 goal, which is very important goal, and can really change the situation if we are going to follow that correctly. But I would like also to refer to two very important impact aspects that are not always taken care of. The first is the fact that we have to add to whatever we are thinking the cost of doing nothing. So if we stop doing nothing about the environment, World Economic Forum, and I have worked with them on this study, they have seen that we are going to pay a cost 1.5 to 2 or 3, even $3 trillion a year. This is most equivalent, more or less, with the cost of tackling the climate change. But this cost is there, and it can transform what is an environmental program and problem to a social problem. What was happened in Thessaly, and Professor Lagouvardos described it, is accurate. Everything was destroyed. And if we are going down to Africa, to Libya, there thousands of lives were lost. So the cost is now social, and it puts a problem, a challenge on the head of governance if they want to do something. And then the third point is that this impact is not spread geographically equally across the globe. There are areas, and Mediterranean is one of these areas, that the impact will be worse, and this is something that we have to have in mind too. So to make a long story short, biodiversity loss, a great problem of cost, and the social problem, and then the third, special areas like Mediterranean. Thank you very much, Cheryl.
No, thank you. Thank you for outlining the complex interrelationship, especially between taking too long to take the necessary action. Moving on to Dr. Lipiatou, can you talk to us a little bit more about Europe, the role of Europe in safeguarding our oceans and achieving the green transition? What are some key policies that are moving things ahead in the European context?
Thank you, Cheryl, about the opportunity to speak about the oceans, which are essential for our life. They regulate the climate and still are constantly degraded and destabilized. The green transition, so the Green Deal, and the digital transformation are European Union's top priorities. And they are both important and necessary for climate neutrality, for Europe's economic development, and for saving the climate. Today, and in line with the overarching theme of the forum, the Great Transition, I would like to introduce the idea of the blue digital transition. A transition that encompasses both the digital transformation and the green transition adapted to the marine environment. in Europe is showing its determination to succeed the digital transition with its policies. Let me quote here the Digital Decade Framework and important recent policies such as this of European Data Act, the CHIPS European Act, and AI Act. Our ability to meet our climate neutrality targets by 2030, as set by the Green Deal, are directly depend on our ability to innovate. There will be no Green Deal without blue economy, and there will be no blue economy without innovative technologies, for instance, in the areas of monitoring, remote sensing, AI, and robotics. We need to work thoughtfully on the nexus, healthy oceans, blue economy, digital transformation, overcome any conflict and work on synergies. It is true that in Europe has seen a rising tide of ocean innovators and investors over the last decade, supported by ambitious policy framework. Yet, we need to accelerate, and we need to scale up at national, European, and international level.
Thank you. And your comments on the importance of digitization and the digital transition to save the environment leads us directly into our next speaker, Professor Haralambides, who is going to talk to us about his work in maritime economics and logistics and the different ways that technology can improve logistics and help the environment.
Thank you. Thank you, Cheryl. Good afternoon. Let me first say that what we call, apologies for my voice, but what we call maritime logistics is just a system consisting of ocean transportation, ports, and infrastructures, and large infrastructure projects. To start, I will start by saying that our industry, our sector, which actually optimizes transportation, and this is its contribution to the environment, is not directly responsible for impacts on our oceans. Instead, the impacts that derive from our sector are through environmental CO2 emissions and those impacts that we try to contain. Indirectly, why? Because contributing to global warming as a result of emissions and international transportation does emit means, for instance, that we contribute to the increasing melting of Arctic ice. This means that navigation there in these waters become more and more easy and attractive, and this is something that we do not like. So we have major companies, carriers, that they say, we will never use those transport lanes for our operations. But no matter what we do, and maybe later we can go in more detail on what it is that we do, we have a number of setbacks. For instance, a great setback that we have these days is what happens at the Red Sea, which means that ships, they will have to navigate around the Cape of Good Hope, 8,000 kilometers more in distance, 12 days more, which means that environmental impacts, emissions from the increasing length of our operations is 50 to 60% higher than before, when ships, they were using the Suez Canal. So we have all those. And of course, it is obvious that when we are building large infrastructure projects like large ports, bridges, we see the recent example now in Baltimore, and so on, those also have impacts on ecosystems, on local populations, and of course, a balance is difficult to strike between environmental sustainability and economic sustainability, because if we don't have the latter, the former makes little sense. What I used to say, the former means that we will have a sea without fish.
True, thank you.
As an introduction.
Yes, thank you.
Thank you
for pointing out the complex balance that has to be made, and to your point about the geopolitical instability and the impact on the sector, it also has additional knock-on effects, economic impacts, industry impacts that are being felt very sorely, I think, from different industries, even in Greece. Sticking with the idea of focusing on specific sectors, I'd like to invite Dr. Ebbesson to offer some thoughts on fishing and aquaculture. It's not just an important part of the blue economy, but it's a critical component of food security. Can you tell us a little bit about some of the biggest challenges being faced by the sector?
Thank you very much for the invitation to be here. So as we've heard already, we see that there's a lot of the changes that are happening now in our ocean are happening maybe even faster and more, the fluctuations are greater than maybe we could have predicted. And a lot of, when we think about aquaculture and fisheries and what we're thinking about the predictions into the long term, we've also often looked at like 30, 50 years, what's this going to be? But the fluctuations that happen now are much, much greater than that. So we have to take care also about what's happening to our populations, of the fish populations in the sea, but also how that affects aquaculture. And one of the most critical things that we need is data. And because we need to be able to monitor these data or these populations in the ocean in a closer scale. We have certain initiatives as the European digital twin of the ocean, you may hear more about this later, that gathers data to be able to understand this. But we need more innovations to get and more data sharing to happen. So I'm coming from the European project, European Digital Innovation Hub, Oceanopolis, where we try to give more digital innovations into the industry to get us more of this data. So for instance, using AI to identify the harvesting of fisheries, and not just maybe giving 5% of what the harvest is, but looking at maybe 80% or 100%, so we can really characterize even the bycatches, and we know where they are caught, how they are. We're using AI for smart fishing, so you're using this to be very much more selective. In aquaculture, data is so important also for being able to use AI for instance, smart feeding, not to waste resources. We have to remember that the ocean is there to possibly be one of the main places for us to get food, but we have to take care of the ocean. So we have to do this really sustainably. So finding ways where we can use modern digital technologies and use them correctly to make new policies and management in a better way is really going to be important. And we see biggest challenge for aquaculture is overfeeding and ruining the sea floors. And this often has to do with some of the new technologies that I'll talk about later.
Okay, so you leave us hanging.
I'll leave you hanging on that.
So I promise to get back to you. And we've also promised Professor Lagouvardos that he will tell us a little bit more about the ocean climate nexus. Within Greece, we experienced some very extreme weather this summer, and we'd like to hear a little bit more about how that happened and perhaps what we should expect in the future.
As we all know, air and water are in contact, so they exchange heat and moisture. That's what we call the air-sea interaction. And when we have warmer waters, this process is much faster and must produce, for example, more water vapor in the air. This can affect small-scale weather systems and large-scale weather systems. I will give an example of a small-scale weather system, which is a thunderstorm. we had in summer 2022 a very warm period in the western part of the Mediterranean, and consequently very warm Mediterranean waters in the western part. And then at the end of August, we have a very big thunderstorm, but thunderstorm is a local phenomenon in Girona. Girona is a city north from Barcelona, with the largest hailstones ever seen in the area in the Mediterranean, 12 centimeters of diameter. It's like my fist. And the scientists tried to simulate this event with the surface temperature we have at this specific day, which was 3 or 4 degrees more than the average, and what we have with the normal values. And they show that, of course, thunderstorm was developed in both cases, because a thunderstorm is an atmospheric phenomenon, but hailstone was much smaller, as we knew so far, than what they experienced this day. And they attributed these changes on the warmer SST and the faster evaporation of water from the surface of the ocean, of the Mediterranean Sea. And then we go to Greece in September, or in a large-scale system. We have a big storm, Daniel storm, formed over the Ionian Sea. Ionian Sea, in the aftermath of the big heat wave we have in July, was about 2 to 3 degrees warmer than the normal values, and then the system produced the excess of water vapor that fed the system, produced the rainfall that we experience in Thessaly area, which was something that we have never seen in Greece on a daily basis. And then the system also became a Mediterranean and affected Libya with the catastrophic problem we have also in Libya. In other words, when we have warmer seas, means that we have stronger weather events, and weather events are more dangerous for our life and our properties. Thank you.
So we should expect, unfortunately, to see more of this in the future.
If we go to higher temperatures on this, maybe we can see things that we cannot imagine even now.
So in an effort to try to put a positive spin on this alarming news, I'd like to go back to the use of technology, how we can implement them to help adopt more sustainable practices, either to mitigate the effects of climate change on our oceans or other positive impacts. Commissioner, do you want to add your thoughts to this?
Yes, there is really a positive aspect referring to all that. We can have a positive, how can I say, spin. So we can see that there is already a great development of the science, of what we call technology innovation. Innovation is a very important word. I agree with that with Mrs. Lipiatou. And I can give you a couple of examples. For example, we have now satellites, and we can see whatever is happening in the sea in real time. I'm participating in the board of an organization called Global Fishing Watch, which was introduced by Google. Google has the technology and whatever. And what we are doing is that we have a map, and we can see every boat, where is fishing, when, what's happening. So this is amazing. So if the people who govern a country would like to do something to stop illegal fishing, then it can be done, thanks to technology. I can give you another example. Now in shipping, there is so much discussion about other fuels that can substitute fossil fuels. In aerospace industry, also, there are similar discussions. Or I can give you another example. I was in Lisbon a month ago in the Economist Conference, and I have seen there a presentation about geoengineering solutions, what we call geoengineering solutions. Some of them are challenging and dubious. Nobody can say it's good and be sure about that this is good or bad, but they are amazing. They can, for example, absorb CO2 from the air and dig it somewhere deeper in the ocean or in an empty space or something. So these are real new ideas. That's why I am more positive about the future. And I can see, though climate change is here biting us, I think that at the end of the day, the real life is going to persuade us that we have to invest and do something. For example, if what Professor Lagouvardos can be true about the Mediterranean, and this is proven true for the Mediterranean, we can have hurricanes in the Mediterranean. And if we are going to have hurricanes, the disasters that happened through Daniel in Thessaly will seem very, very little. So can you imagine these situations? I think that the fact that humanity refuses to react now is because of the cost and because nobody would like to sacrifice their way of life. And the changes that are needed here are very costly, and going back to our culture, the personal culture of consumption, of the way of life of everybody of us. That's why it's so difficult. But the life is going to persuade everybody, and then I trust that science and technology can do their best. So I'm positive at the end of the day. I choose to be positive, to be honest.
So we'll stick with your message of positivity and also the fact that the tools are there. We just need to start implementing them. I saw a lot of head nodding from Dr. Lipiatou and also Dr. Ebbesson. So if you'd like to both, whoever would like to pick up on this question about innovative technologies.
Okay.
Oh, Professor Haralambides as well.
Sure. We do a lot of things at long last, because for many, many years we weren't doing anything. And actually, I consider it a shame that for decades shipping, international transportation was burning what we call sludge, which is the lowest level in the refining process. We do a lot in terms of ship efficiency, propulsion efficiency, management efficiency. But still, as the Commissioner said, the major problem is alternative fuels. It will be years before we can have a reliable, sufficient supply of non-fossil fuels, particularly if we want to reach our very ambitious target that we have set to ourselves, the International Maritime Organization, for instance, of a net zero by 2050. This is rather optimistic, in my view, in terms of attaining this. Fuels, we will not have enough for many, many years. Still, 90% of the ships, they are burning fossil fuel, including LNG. What can we do in this regard? Give disincentives for burning fossil fuel and incentives for entrepreneurs to renew their investment, their assets, with modern technologies that use renewable energy. Some of them do this already, the big ones, more like a marketing proposition that, look, we are pioneers and we are ahead in this transition. The others, it will be difficult. Solutions, ETS, emissions trading systems. The European Commission has decided very correctly to include international shipping in the ETS system, whereby we put ceilings and we trade in certificates. It's a complex system. Or a heavy fossil fuel tax, a tax on fossil fuel. And this would be the market-based mechanisms that we can endorse, we can use, we can enforce until time comes when we have newer investments, technologies, and fuels.
Thank you. So I'm hearing again the importance of the economic and financial considerations as key incentives. Dr. Ebbesson?
Yeah, so on that note, on towards the positive side, And I think for aquaculture, which is surpassing the fisheries in the harvest, they are coming with a lot of problems now because of the changes in the ocean. You're having the changes in the microbiome, you're having new threats to the aquaculture that haven't been thought of before. But some of the new innovations, such as semi-closed systems that are they're a protection of the aquaculture, the fish, from the outside. These types of systems can really help protect the production, but also the environment. In this way, you're increasing the circularity, so you're collecting up to 96% of the particulate waste. You can have secondary production, such as kelp or mussels, that are collecting through a mass balance removal the nitrogen species, the CO2, the phosphorus out of the system that can really help balance what the aquaculture is producing. So I see that there's a lot of innovations that are coming, and a lot of it, these type of systems are dependent on digital innovations. Because of the complexity of them, you need that. And so I'm really positive towards the future of how we can use these new technologies to take care of our ocean.
Thank you. Dr. Lipiatou, I don't know if you want to add something on that, or if perhaps you want to talk a little bit more about some more promising initiatives that are aimed at protecting marine habitats. I'll let you choose.
Yes. I think on that I take the opportunity to highlight the European digital twin of the ocean. What is a virtual representation of the ocean, a part of the Destination Earth initiative, a virtual representation of the Earth, which is financed by the European Commission. So the European digital twin of the ocean, announced by the Commission President, is aiming to restore our oceans and support blue economy with a 2030 target. So now, what is the digital twin? It uses real-time and historical data, as well as numerous satellite data, including through Copernicus, advanced numerical modeling, artificial intelligence, machine learning, and high-performance computing to generate the knowledge that they need entrepreneurs, the policymakers, the citizens, and researchers. The first version, it will be deployed this June 2024, and it will be available in open source. I can give you now a concrete application of the use of this digital twin in the Mediterranean Sea. Every year, we expect up to 2,000 incidents of operational oil spills in the Mediterranean basin. Local authorities responsible for oil spill monitoring and their risk assessment need to act with urgency and be able to immediately access data, reliable data, to understand how the pollution is spreading, to develop scenarios, and try to know about their potential impacts. With a digital twin, they will be able themselves to access relevant databases and computer scenarios directly on a cloud platform. They will be able to access information for detecting what coastal resources could be at risk from the oil spill and act accordingly. And if I can, I have just to say that I would like to quote what the Commission President said. She said, "We do not have yet all the answers, but Europe, it is Europe's man to the moon moment." I think the synergy of digital transformation and green transition is needed to save our oceans, to achieve climate neutrality and develop Europe's economy. A blue digital transition is crucial and at all scales, at national, at European and international. And all of us, we have a role to play.
Thank you for that encouraging news about these new technologies. We're coming to the end of our panel. I would like to ask each speaker to make one quick 20-second statement, the core of your message, and then we'll wrap it up.
There is no climate deal without the ocean.
Thank you. Professor Haralambides?
We protect our oceans not because it is our livelihood, but because through the oceans we promote our welfare, which is trade.
Thank you.
We need to work on the nexus: healthy oceans, blue economy, digital transition.
Dr. Ebbesson?
The ocean is where food's going to be important in the future, and digitalization is going to be a critical point in making sure that we do it right.
And Professor Lagouvardos, your final
We have
words?
a big problem, but as Maria Damanaki said, we have to think positively.
Yeah.
Okay.
Thank you. So I'd like to offer a round of applause to our speakers today. That brings us to the end of our panel.